Wait, are you recording now?
Yeah.
I was close.
Okay, we're going to go over periodic functions. And what I have here is a list of graphs, and we're going to talk about how they are or are not periodic. So a periodic function is something that has to repeat. It has a repeating pattern to it. So if we quickly take a look at this, we can see that this has a repeating pattern. Okay, kind of looks like mountains in this case. It could be representing maybe like a heartbeat or something similar to that. Could be used in the medical community. Who knows what it's measuring? Okay. But what we want to do is we want to be able to pick out some important parts of periodic functions. First of all, we want to be able to figure out what a period is. And a period is how long it takes for the function to repeat. So let's assume that this x-axis is in ones. Okay. So this is 1, this is -1. And every box represents 1 unit. Same with going upwards and downwards. How long would you say it takes for this periodic function to repeat? 3 units, right? If we were to start here, we count over 1, 2. It takes 3 units. So the period is 3 units. Okay, let's highlight it. That represents 1 period.
Mountain.
Yeah, it looks like a mountain, I know, but it's measuring. And I probably should have given us, let's go with we'll call this pressure over time. Okay, so here, pressure is mounting, it releases a little, mounts a little more, releases, and then it does a negative, so you could say it's opposite of pressure, it's releasing pressure, then it starts to build again, release, build again, release, build again. Okay, we'll call it pressure in this case. So the period of this cycle, maybe it's a machine like a nail gun or something like that. And we're watching how the pressure mounts in this nail gun. This is the periodic function of it. What would be considered the peak of this? Or what would be the highest pressure? Yeah, 2. Oops, that's the wrong one here. Okay, so if we go straight across, all of these here are called the peaks. And there's many different peaks. Okay? Because it's a periodic function, we have 1, 2, 3, 4, and it's going to continue. We have 4 different peaks being shown, and they're all at the value of 2 here. So maybe it's 2 pounds per square inch, something like that. Right now, I just want you to be able to recognize on a graph that this would be considered the peak. The trough would be the opposite of it. What would be the trough of this? -1. That's right. I'll try to give it a different color here. Okay. So the trough, -1 pounds per square inch. So these are all of the troughs, and because it's a repeating pattern, okay, it hits this trough many different times. Okay, so we have our peak, our trough, and we have our period to this function. It's obviously a repeating pattern. Okay, and for this to be considered a periodic function, who remembers what the rule was for a function? What test did it have to pass? What's it called? The line test, or what type of line? Is it a horizontal line?
Line of symmetry.
It's a vertical line, right? We have to be able to pass a vertical line test. So if we continuously draw vertical lines through this, we should only hit the function once every single time, and that happens to be the case. Okay, so that makes this a function. This is a periodic function. Okay, so we've just witnessed what a periodic function might look like. So let's go down. This function here, same idea. We're going to call the units all moving by a value of 1. So 1 and -1, 1 and -1. Okay, each of the squares represents a unit. What would be the... Well, actually, let's start with the easy ones. What are the peaks of this unit? 2, same as before, right? But there's a little bit of a difference. This one has a more circular type motion to it. And we're going to talk about what that is. What is the trough of this? Yeah, we're at -2. Okay, so there's several troughs. In fact, there's the same amount of troughs for each of the peaks. What is the period of this function? How can we tell the period of a function? Is it just from the peak to the trough? What does a period represent? Yeah, one way to measure, you could go trough to trough or peak to peak, because this one works that way. Now, in this one here, it was the same idea, right? from trough to trough or from peak to peak will let us know the period. And no matter what we did, if we went peak to peak, that was 1, 2, 3 units. If we went trough to trough, that was 1, 2, 3 units. Our period was 3 units. In this case, let's go peak to peak. This goes 1, 2, 3, 4. So the period of this function is actually 4 units. Okay, and that's how long it takes for the repeating pattern to get back to where it started, or in other words, for this cycle to complete itself and then continue again. So this would represent the period of the function. So the period was, we'll call it 4 units. I guess there's a little more we could talk about. What about the range? Let's go back up to this. What would the range of this be, and how can we figure out the range? Yeah, the range would be from the peak to the trough. So we've drawn 2 lines here. Remember, our peak was 2 units and our trough was -1. How can we figure out how far apart that is? We could count. What if we had like very large numbers? Subtract them. Our range is taking the peak and subtracting the trough. So the peak is 2, the trough is -1. 2 subtract -1 is 3. The range of this unit was 3. What about this one here? We'll draw some lines again to help us out. Okay, from peak to trough. Does anyone know what the range of this is going to be? Yeah, the peak minus the trough is our range. And our peak was 2, our trough was -2. We subtract the 2 values. We have a range of 4. Okay, now this type of function is very important. Okay, this curve gives it actually a very specific type of periodic function. It passes the vertical line test, so it is a function. This is known as a sinusoidal function. Okay, a sinusoidal functions have a wave-like pattern. This above was not sinusoidal. Okay, it's very linear. Everything about it was very direct, very sharp. Okay, this wave-like pattern is called a sinusoidal function. It's important because we're going to talk more about that. Okay. The other one is just a periodic function. Now, they both technically are periodic. This one was periodic. I put it P. Okay, let's write that above. Periodic. The above is periodic. This below is also periodic, but it's a very specific one called sinusoidal. And I want us to remember that as we go through. So, when we look at this third example here, is this, example 3, is this a periodic function? Well, to be sinusoidal, it has to be periodic. Is it periodic? Yes or no? Who can help me? Yes? Okay, where is the period, or what would be like a peak to this period? Okay, so again, let's say in this case it's actually going by 2s. So this is 2, -2, 2, and -2. Each of these squares of these units is a value of 2. Okay, let's take a look at our peaks. We have one peak here, another peak, another peak, another peak. Okay, and what about our troughs? We have a trough at -6 here, and another one at -6. If you notice, that was a little low, but our troughs, there's only 2 troughs for 4 peaks. So remember, before we went from peak to peak to measure the period, we won't really be able to do that. This is a periodic function. It does have a repeating pattern. Who can tell me what the pattern is? Yeah, we have like a small semicircle, then a large, almost like half an oval, semi-oval, right? And then the pattern repeats. So let's try to figure out how long the pattern takes. Let's say we start from here. Okay, is one cycle back to the peak an entire period? No, so we can't use that. But if we go peak down to trough and then back up to peak, this would be considered an entire period of this function. Okay, and this has a repeating pattern to it. This one wasn't so good. There you go. This would be the period of this function. Okay? So the period of this function is a little different. It goes from 0 2, 4, 6, 8, 10, 12, 14, 16. So it is 16 units. We'll call them seconds in this case. Okay, we'll say this is time. So 16 seconds for this function to repeat. Okay, so it's very important that you notice that it's not always going to be one pattern. There may be several small patterns mixed together that completes an entire cycle. Okay, is this sinusoidal? Remember, sinusoidal had a wave, right? So it waved down and then waved up and back and down. Okay, what would we call this? Would you call this periodic and not sinusoidal, or would you call it just periodic? I would say this is just periodic. In fact, it doesn't have that wave-like pattern. The wave-like pattern, in order for this to work, okay, would have to go down and then come back up, down and up. Okay, because this is very sharp at its peaks, its troughs are very wave-like, but the peaks are very sharp. Okay, what I mean by that is it changes direction very quickly. A sinusoidal function is very gradual as we go through, a wave-like pattern. Okay, so this one would be just periodic. It would not be considered sinusoidal. Finally, the last one. Okay, does this have a repeating pattern? Yeah, what are the peaks and troughs? Let's say it's going by threes this time. Okay, so peak is at what value? 6. Okay, so we have 3 peaks here. And our troughs? That's right. -6 for our 3 troughs. Excellent. What is the range? You guys remember the range? We go from the peak to the trough. We take the peak and we subtract the trough. So the range is 6 subtract -6. 12. So we have a range of 12. Quickly above, I know we didn't talk about it. What was the range of this function here? It went by 2s, remember? So 2, 4, 6, 8. From the peak to the trough was 8 units, okay? But more importantly, we figured out the range here, we figured out the peak, the trough. The period, what would you kind of call the period to this? We start here, and it looks like at the same time it's going up and back down, and it's going down and back up. How far would you call this period? How long does it take to get here? 4 by 3? Oh, right, 12 units. But this is the most important part. Is it a function? This is not a periodic function because if we draw the vertical line test, it's crossing the unit twice. Okay, so this is not a periodic function. Just someone drew a couple circles on it. You may get patterns like this, okay, but there's no technical, this is not technically a periodic function because it does not pass our vertical line test. Okay, but we were still able to, if asked, we were still able to find the peak, the trough, the range, and even what could be called a period.